I am really delighted today to welcome Johann Gaebler, a PhD candidate in statistics at Harvard University and a Stone PhD scholar studying the measurement of discrimination. Hans focuses on applying data science and statistical tools to complex social issues such as mass incarceration and hiring discrimination. His research interests span causal inference, computational social science, Bayesian statistics, machine learning, and algorithmic fairness. Before coming to Harvard, Hans was a PhD student in computational and mathematical engineering and a Knight Hennessy Scholar at Stanford, where he worked at the Stanford Computational Policy Lab. His interdisciplinary approach aims to bridge statistics, computer science, and policy to address pressing social challenges. So we're delighted to have you, Hans. Thanks so much.
Thanks so much, Ravi. I should say I'm very happy to take questions during the talk. So if anything is confusing, please feel free to stop me. I'd be more than happy to kind of. I need to share the screen. Yeah. Okay. Are the people on Zoom able to see my slides? Okay, great. Okay. All right. Thanks so much, everyone, for being here today. Thanks, Ravi, for the introduction. It's a huge honor to be here and speak with all of you. So I'm going to talk about some joint work with my advisor, Shara Goyle, on sort of outcome tests and the measurement of discrimination. Okay. So just to kind of like motivate what I'm going to be talking about, let's imagine that you are a statistically savvy financial auditor and you happen to bank at the local Wells Fargo, entirely fictional bank. And let's imagine, completely hypothetically, of course, that Wells Fargo has gotten a bit of a bad reputation for, I don't know, I'm just making this up, fraudulently opening accounts in people's names without their consent, charging people for auto insurance they didn't ask for, that kind of stuff. And maybe you hear some rumors also about discriminatory lending practices. And so you decide to investigate. And so a very natural first thing for you to do is try to dig up some data on who is getting approved for loans. So let's say that you find that 91% of applicants from the majority group have their loans approved, while only 87% of applicants from the minority group have their loans approved. I should say at the outset, so for simplicity in the whole talk, I'm going to frame everything in terms of a majority group and a minority group. By that, I don't mean that the majority group is like larger in a numerical sense. I just mean that if you're told that one group was receiving favorable treatment and you had to guess which group it was, it's the group that's sort of like the better bet. Okay, so the important question is, what can we learn from this? And there's a lot of law around what constitutes fair lending. But the basic question that legislation like the Fair Housing Act and the Equal Credit Opportunity Act ask is, does Wells Fargo use the same standard to decide to whom to make loans across groups? So in other words, do you have to be more creditworthy to get a loan if you're a minority loan applicant? And at this point, I should point out that there's no like one consensus definition of what discrimination is, but I think this particular definition, so the idea of using different standards, is very important legally. It also has a long history in kind of the economics literature. And so it's a worthwhile question to understand, and it's what I'm going to focus on today. And this is already kind of a long talk. So when I use the word discrimination, just know that it's a shorthand for this sort of idea of using different standards. And I'm going to make this more kind of mathematically precise in a moment as well. But okay, so if that's our goal, then the obvious answer is that we probably can't hope to learn too much from just comparing lending rates for the simple reason that there are lots of omitted variables here, right? There are all sorts of things that could explain this difference, even if Wells Fargo isn't discriminating. And just looking at the raw lending rates is not really doing anything to sort of account for those factors. But even so, this difference in lending rates is a pretty standard thing to look at. And it's usually the jumping off point for kind of more sophisticated statistical analyses of discrimination, excuse me. It's such a natural thing to do that people don't always give it a name, but when they do, they usually call it the benchmark test because we're benchmarking the lending rate for the minority group against the lending rate for the majority group. Excuse me. Okay. So Gary Becker, who kind of at least to my knowledge, founded the study of discrimination in economics, was, I think, one of the first people to observe that the benchmark test is not a very reliable test of discrimination. So in his Nobel Prize acceptance speech in 1992, he said that recent studies on whether banks discriminate in their mortgage lending compare the likelihood of getting a loan for minority and white applicants. Unfortunately, these studies do not use the correct procedure. What's sort of interesting, though, is that Becker also proposed a solution. So he said that if banks discriminate against minority applicants, they should earn greater profits on loans actually made to them than to majority applicants, right? So this was a little bit confusing, I think, the first time I heard it, but the intuition is pretty straightforward. So we imagine that the repayment rate for minority borrowers were, say, 95%. But for majority borrowers, there were only 30%. That would be a pretty strong signal that the bank is holding minority borrowers to loan applicants to a very high standard, and it's only lending to people who are like exceptionally qualified to get a loan. So this alternative test of discrimination is known as Becker's outcome test because it looks at the outcomes of the decisions, in this case, whether or not somebody repays the loan, rather than the decisions themselves. And in part because it's so simple, the outcome test gets used all the time, kind of both in and out of academia. So it gets used for maybe slightly navel-gazing purposes, like of interest, great interest to academics, like looking at whether articles are held to different standards, depending on the ideology of the authors and the editors. So here in this paper, the author's hypothesis is that same ideology articles would have fewer citations if journals cited them, sort of in parallel to the group receiving favorable treatment, paying their loans back less often in the Becker kind of like lending model. It's also been used to study discrimination in medical decision-making. So this is an excerpt from a study looking at COVID test positivity rates that concludes that minority patients were only tested when they were sicker because their tests came back positive more often. And I think the kind of the most common application of the outcome test, and one that I'm going to talk a little bit more about at the end, is that it's frequently used to try to detect discrimination in policing. So here, the outcome in this example is recovering contraband during a traffic stop. And so a lower repayment rate here is sort of analogous to recovering contraband less often. Okay, so let's say that we've read Becker's Economics of Discrimination, and we've come back and we're going to try again to audit Fels-Wargo, right? So they give us access to their loan data, and we perform the outcome test by calculating the repayment rate for both groups. Okay, and we find that the repayment rate for majority borrowers is lower than for minority borrowers. So this is exactly what the outcome test said we should see if minority borrowers were being held to a higher standard. And so the question is this now sort of compelling evidence of discrimination? And to answer that question, I think it's worth spending a time being a little bit more specific about what the exact kind of like model is here. So the idea is that somebody's walking into a bank and they're going to talk to a loan officer. And when they do that, they're going to fill out a loan application. And all of the information that the loan officer sort of gets from this interaction, we're going to call X, right? So importantly, we want to allow for the possibility that the loan officer is discriminating. And so X is going to include the group membership of the person, but it also includes, say, their credit score, you know, what kind of collateral they have, blah, 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 like all the factors that you might imagine a loan officer asking about. And then the next step of the process is that the bank is going to use that information to try to estimate the applicant's probability of repaying their loan. So we don't need this assumption, and this is something that I can come back to and talk about a little bit more at the end, but just for simplicity in the talk, I'm going to assume that the bank does this perfectly, right? So they perfectly estimate the probability given these covariates that somebody will repay their loan. And then the bank has to make a decision about whether or not to actually make the loan to the person. And so again, we don't need this, but for simplicity, I'm going to assume that the bank is sort of like rational in the jargon, which means that there's some threshold TG where they're going to lend to everybody whose probability of repayment is above that threshold and nobody below that threshold. Okay, and so the thing that I haven't mentioned yet is sort of how discrimination actually enters this setup. And so the way that that's going to happen is we're going to imagine that the threshold might depend on whether the applicant is a member of the majority group or of the minority group. Okay, and then finally, if the applicant gets a loan, they're either going to repay the loan or they're not going to repay the loan. And the key statistical challenge here is that we're going to assume that we can only observe kind of the very end of this process. So we'll assume we know for an applicant whether they got a loan, and we'll assume that we know whether or not they repaid it, but we're not going to assume that we know anything about the factors that went into making the lending decision. And in particular, and so this is kind of like the promised formalization of the question I was raising before, is what we want to answer is the threshold in this model for the majority group less than the threshold for the minority group, right? And so for the rest of the talk, when I say discrimination, I mean sort of like mathematically, this is my question. Okay, so again, in this setup, even the outcome test is actually not very compelling evidence of discrimination. So it's entirely possible that Fels-Wargo is lending in a non-discriminatory way, and you would still see these results. So for instance, a common pattern that you see is that discrimination in some earlier stage means that only more than typically qualified minority applicants are even making it to the point of applying for loans. Right, so we could imagine that the sort of like risk distribution, right? So the distribution of R on the previous slide, how likely people are to repay their loans, is right shifted for minority applicants, right? So minority applicants, a typical minority applicant is more likely to repay their loan than a typical majority applicant. And so that's kind of what you're seeing in this plot here with these two curves. And the point is that even if Fels-Wargo has the same lending threshold for everyone who comes in the door, which here I'm showing, sorry, I realize people on Zoom can't see me pointing at the board, but this dashed line down the middle here at 50%, we're imagining that's Fels-Wargo's lending threshold. Even among people who get loans, the typical blue minority applicant is going to be more creditworthy, which is what this blue dotted line is showing. So the average minority applicant who gets a loan has a 71% chance of repaying it, versus the average majority applicant who gets a loan has a 64% chance of repaying it in this particular setup. In particular, we could even imagine modifying this example so that we even lowered, say, the threshold for the blue group, and that's not going to change what the outcome test is telling us. It's only going to change these percentages by a little bit. And so the outcome test is going to tell us that the bank is discriminating against the blue group, when in fact, it's actually favoring the blue group, right? And so this phenomenon is known as inframarginality. And the reason for that is the repayment rate is not just a function of the bank's kind of marginal lending threshold. It's also a function of the whole distribution of risk. So it's not just telling us about this threshold, which is the question we're trying to ask about. And unfortunately, this is not just a theoretical possibility. This comes up all the time in practice, as we're going to see a little later in the talk. Okay, so inframarginality is a very kind of well-known problem with outcome tests. In the kind of the 30-ish years since Becker's Nobel lecture, there's been a lot of work trying to figure out how to get around this issue. So for instance, there's been some work from the early 2000s that looked at trying to get around it by looking at equilibria, where we model the actors involved as kind of in a particular kind of rational economic agent. There's been a variety of work that tries to leverage differences between individual decision makers and what groups those decision makers belong to deal with inframarginality. And there's also been work that uses some parametric assumptions to try to help identify the thresholds and the risk distributions involved. And so as you can maybe imagine from the fact that there are kind of so many different solutions to the problem, that none of them has maybe been like super satisfying. But, you know, I guess an important piece of context is that outcome tests do often seem to give sensible answers. And also a lot of people, and especially policymakers, run outcome tests all the time, right? Sometimes because it's all they know how to run, because it's very simple, but also for data reasons, it's often all that you can run. And so it'd be useful if we can sort of recover something a little bit more statistically grounded from the outcome test. Okay, so to make some progress on the problem, it's useful to revisit this counterexample we were talking about before. So in particular, let's look at the lending and the repayment rates at the same time. So remember, I said that at Fels-Wargo, the majority borrowers had a 64% repayment rate, and the minority borrowers had a 71% repayment rate. And that was like exactly mapping onto this setup where Fels-Wargo had a uniform threshold for making its lending decisions, and the risk distributions just looked slightly different. Okay, well, what about the lending rate? So we said that the lending rate, yeah. Did I say this backward? No. Yes, I did say backward. Good. The lending rate. So we said that the lending rate was 91% for majority applicants versus 87% for minority applicants. And that doesn't match this setup kind of at all, right? So in particular, I said that the repayment rate for majority applicants was lower than for minority applicants, and the lending rate for majority applicants is higher than for minority applicants. But in our counterexample, you can see that both the lending rate and the repayment rate are higher for the minority group, if this were really what Fels-Wargo were doing. And so this suggests an intuition, which is that if there's not discrimination, as there isn't in this setup, then the group with the higher lending rate should also have the higher repayment rate, right? If the differences are really coming from the risk distribution, you'd expect to see both of these rates sort of be higher for the same group. Or in other words, it shouldn't be possible for the outcome test to point toward discrimination, which in this case, it does because the repayment rate is lower for majority borrowers, and for the benchmark test to point toward discrimination, which in this case, it also does because the lending rate is the lending rate is higher for majority borrowers. Okay, so the robust outcome test is just a formalization of this intuition, right? So let's imagine that we see a lower repayment rate for the majority group than the minority group, right? So this is the outcome test saying that there's discrimination against the minority group. And let's also imagine that we see a higher lending rate, right? So this is the benchmark test saying that there's discrimination against the minority group. And then, because both tests agree, we're going to conclude that there is discrimination against the minority group, right? So we're going to conclude that the lending, in other words, we're going to conclude that the lending threshold for minority applicants is higher than for majority applicants. Okay, but there is a catch, and the catch is that if both the lending rate and the repayment rate are higher, then the test is inconclusive, right? So it could be that what we're seeing is the result of discrimination. It could also be that this is sort of the result of a uniform decision policy for both groups, and there are just differences in the risk distributions. We're just going to say we don't know on the basis of this data, these data. Okay, so here's the kind of the key question, right? We saw that comparing lending rates in the benchmark test and outcome rates in the outcome test, both could sort of be wrong, right? They could say that there was discrimination when actually the lending thresholds were the same, or even kind of in the opposite direction of what the test was indicating. So the question is, can the robust outcome test also be wrong? Yes.
I have a question from Jennifer in the chat.
Okay.
Jennifer asks, Hans, are we assuming that the goal of Fels-Wargo is to have the repayment rate the same across groups?
No, we're assuming that the goal of Fels-Wargo is to sort of make money, basically. So they want to make loans that get repaid. But legally, Fels-Wargo, sorry, I have to catch myself since you're recording this. Legally, Fels-Wargo has an obligation to use the same lending threshold for both groups. But the repayment rates could differ. If what Fels-Wargo is doing kind of like the quote unquote the right thing, you would still see different repayment rates because of this inframarginality. Okay, so we saw that comparing lending rates in the benchmark test and outcome rates in the outcome test both could kind of lead us astray. So can the robust outcome test also be wrong? And the answer is yes. So here's an example where the robust outcome test would tell you that there is discrimination against the minority group because the lending rate is higher than for the majority group, but the repayment rate is lower, right? But maybe I said it backward, sorry. The lending rate is higher for the majority group and the repayment rate is lower. But in fact, there is a uniform lending threshold again that I've just sort of arbitrarily put at 50% here. Okay, so to understand what went wrong, it turns out that the right thing to look at turns out to be the proportion of people in a given group as a function of risk. So in our first example, where we kind of got the idea for the robust outcome test, we had densities for risk distributions that looked like this, right? They had similar variances. In fact, they had literally equal variances, and they crossed exactly one time. And in particular, if we look at the proportion of people who belong to the majority group as a function of risk, we see that this is it's a monotonically decreasing function, right? So this is exactly what we should see here. Most high-risk borrowers come from the majority group. And as the probability of repayment increases, more and more people are coming from the minority group. And I should also say, since this is kind of a statistical audience, this is not how people usually write it down, but I should note that this is equivalent to the risk distribution satisfying the monotone likelihood ratio property. I think the way that I've written it here is a little bit easier to kind of reason about. So I'm going to like stick with that way of representing it, but mathematically it's the same thing. Okay, in contrast, in the example where the robust outcome test failed, things looked very different. So the two risk distributions had very different variances, and in particular, they crossed twice. So in particular, this means that the problem of estimating whether someone will repay their loan is actually easier for the minority group, right? So for most people in the majority group, their probability of repayment is around 50%. It's sort of a coin flip whether or not they're going to repay based on the information you have when you make the loan. But for many people in the minority group, you know when you make the loan, or when they apply for the loan rather, that they're very likely to repay or they're very likely to default. Okay, and now if we look at the proportion of people who belong to the majority group as a function of risk, we also see something very different in this example, right? So now our function is non-monotonic, right? It starts kind of very low, it starts at 0 and it ends at 0, and it's high in the middle, because the minority loan applicant's risk distribution has a lot of mass near 0 and 1, whereas the mass for the majority group's risk distribution is concentrated near 50%, right? And so in particular, if we look at this probability as a function of R, which is what's shown on this plot, it's not monotonic. Okay, so we have kind of these two different worlds, right? So in the first world, we saw the probability of belonging to a particular group being kind of a monotonic function. And we also have this second world where the probability of belonging to the majority group was a non-monotonic function of risk. And in the monotonic world, the robust outcome test seemed to work. And in the non-monotonic world, it failed. Okay, so here's like a theorem, right? So the theorem is, suppose that the probability of belonging to the majority group as a function of risk is monotone in risk, and that the outcome test says that there is discrimination against the minority group, and the benchmark test says that there's discrimination against the minority group, then it really is the case that the lending threshold for the majority group was lower than for the minority group. Okay. So before moving on, I do want to say this is not like the kind of like the quote unquote best theorem that I could have given you. As I mentioned a few minutes ago, you can relax a lot of these assumptions in important ways, and I can return to that at the end if people are interested. But there are a few assumptions in this theorem, and one that you can't relax so much that you should maybe worry about more is this monotonicity assumption, right? So I want to spend a few minutes talking about that. Okay, so what does the monotonicity assumption mean? So it is an assumption, right? We looked at an example where it didn't hold, but at an informal level, we roughly should expect two risk distributions to satisfy our monotonicity assumption when we don't have more information for one group than for the other, right? So we see this in our risk distributions from the fact that in our top example here, the variances are the same, whereas in the bottom example, the variances are very different, right? And so in the top example where the variances are the same, there's roughly as hard to predict for one group as for the other who's going to repay their loans. Whereas in the bottom example, remember we said that for the blue group, there were lots of people where we could predict very well. But for the red group, there were most people we had, no idea really whether they're going to repay their loans a lot or not. Okay. I do want to point out before moving on that this intuition is really sort of sufficient rather than necessary. So you can also have distributions that have very different variances that also have different means and satisfy this condition. So it's really much broader than this. But the point, I think, is that the intuition that we should be seeing this a lot in practice is coming from the fact that we should expect to see this monotonicity property holding roughly when the problem is not harder for one group than for the other. And so in particular, if you see that the problem is much harder for one group than the other, I think it's reasonable to wonder whether the decision maker is maybe ignoring important features to sort of mask some kind of discriminatory intent. So redlining, for instance, is an example of this, where lenders ignored key kind of indicators of individual creditworthiness so that they could justify denying loans to racial minorities. Okay, so one nice thing is that many kind of familiar parametric models that people use to model these kinds of risk distributions satisfy this monotonicity property. So for instance, if we model the risk distributions as beta distributions with the same variance, that will satisfy the monotonicity property. And in fact, slightly more is true. As long as the distributions only cross once, they'll be monotonic. Same is true of gamma distributions. Normal distributions with the same variance satisfy the monotonicity property. Binomial distributions with the same count satisfy the monotonicity property. So again, intuitively, this is something like saying that you have the same amount of information for both groups. Logistic distributions with the same scale are ordered or have this monotonicity property. And in fact, any monotonically increasing transformation of a pair of distributions that have the monotonicity property will still have the monotonicity property, right? So you can have log normal distributions, logit normal, log gamma, et cetera, et cetera. Okay, so this is a pretty broad class of models to work with, but the kind of important question is, does this actually hold in practice, right? It's nice that theoretically it's easy to set up models where this is true, but is it actually true in practice? And in practice, it actually does seem to be an assumption that holds empirically in a lot of domains. So this is an example of risk distributions from real lending data, not from Fells Wargo or any other bank that you might guess based on that name. And the x-axis here is showing overall deciles in the distribution of risk. And the y-axis is showing the probability that an individual in that risk bucket belongs to either the indicated racial minority group, so Black or Hispanic, or is white. All right, and so the red line is showing the proportion of people in the first risk bucket who are Black versus white. Blue line is showing Hispanic versus white, and it's showing across all the different risk deciles. And so in particular, what you can see is that we generally see this monotonicity property holding, although when we compare Hispanic and white individuals, it's really kind of flat rather than monotonic in either direction. We also see monotonicity in criminal justice. So this is looking at risk distributions from New York City's stop and frisk, where risk here is sort of somebody's ex-ante probability of possessing a weapon. This is another example from criminal justice using COMPAS data from Broward County, Florida. And you also see this in admissions data. So for instance, this is showing monotonicity for law school students. Again, this is all real data where the outcome that we're looking at is whether or not somebody passes the bar. And we're estimating that probability using like their LSAT score and the other application materials they provided when they applied to law school. I should say that in all of these examples, monotonicity is obviously only holding approximately, and you would not expect more than that to hold in any real world data set. Yes, right.
If you looked at like Black versus white or Hispanic versus white for all these examples, would you see the same thing?
Maybe I wasn't clear. This is Black versus white.
Oh, it says Hispanic.
The blue one is Hispanic versus white. Red one is Black.
I see. Okay.
So it's showing the ratios, not the density. Does that make sense?
Yeah.
Okay. Okay. So, right, again, so just to quickly kind of reiterate that point, it's like, they look pretty monotonic, but like if you look over here, it's not like literally monotonic. And so maybe we have to worry about that. So, especially because any data set that we'd like to apply the robust outcome test to is going to be a real world data set where it is in some sense literally guaranteed to not actually be perfectly monotonic, right? So we want to try to understand how robust the robust outcome test actually is. So the natural way to do this is with our empirical risk distributions, right? So what we're going to do is we're going to take those risk distributions as ground truth, and then we're going to simulate a decision maker who has different decision-making thresholds. And we're going to look at what the sort of decision rates and outcome rates, or the lending rates and the repayment rates basically, are across a bunch of sort of discriminatory scenarios, and then also non-discriminatory scenarios. And we're going to see what the robust outcome test is telling us in those cases. Okay, so to study this, let's start by looking at the lending data. So here, the x-axis and the y-axis are showing simulated decision thresholds for Black and white loan applicants in the lending data. Just the overall distribution of risk, right? So the 25%, the 25th percentile for everyone in the data. And so the dashed line is showing scenarios where, according to our definition, there's no discrimination, right? The dashed line is scenarios where the bank is using the same lending standard for both groups. The area above the dashed line is showing scenarios where the bank has a lower lending threshold for white borrowers, which is what the little X's are showing. And the area below the dashed line with dots is showing scenarios where the bank has a lower threshold for Black borrowers. And then the colors are showing the results of the robust outcome test, right? So the blue areas show where we're finding that the decision maker is favoring white borrowers, where the robust outcome test says that the decision maker is favoring white borrowers. Yellow is where it's inconclusive, and red is where it's favoring Black borrowers, right? So essentially what we're seeing here is that across these scenarios, even though we don't have perfect monotonicity, the robust outcome test is essentially always correct anyway. So when it says that there is discrimination against a group, that is in fact almost always the correct inference, right? Though as expected, in a lot of cases, it's inconclusive. We can compare the robust outcome test to Becker's standard outcome test, right? So this is the one where we don't look at the benchmark test. We don't look at the lending rate. And what we see here is that the standard outcome test is actually wrong all over the place, right? So there are lots of scenarios where it suggests that there is discrimination against, in this case, white borrowers, when in fact exactly the opposite is happening, right? So it's not kind of a reliable signal. Yes.
So maybe I need to think about this more, but if you were to simulate a lower threshold for a group, then that would mean that certain people who previously didn't get the loan now get the loan.
Mm-hmm.
How do you know whether they repay it?
We're taking the risk distributions as ground truth. So imagining that this risk distribution is the true, right? That there's no confounding in the people that we observed repaying versus the people we didn't observe repaying. It's if you actually went out and estimated these risk distributions kind of like in the wild, you would have to worry about that. But we're just trying to understand as kind of a simulation exercise, like how far off can these distributions be from true monotonicity, and the robust outcome test will still work. Does that make sense? So this is not something, if you're going to run the robust outcome test, I'm not proposing that you go out and do this step. Okay, and so the kind of like key point here is that we actually see the same basic pattern across all of our real world data sets, kind of despite monotonicity being only approximately true, right? So the robust outcome test is almost always a reliable signal of discrimination. And the way that you can see that is the dashed diagonal line is always like essentially completely contained in the yellow region, whereas the sort of the colored regions where it's picking up on discrimination are on the right sides, right? It's picking up discrimination in the right direction. So when it says there's discrimination, that is actually what's going on. On the other hand, with the sort of standard outcome test, you can see that all over the place, there are, it's giving us the wrong answer. In particular, it's sometimes saying things backwards. So like if you look at the contraband example, there's like huge areas where you could be discriminating. It's like very hard for the outcome test in that case to say anything other than there's discrimination against the blue group. Okay, that's a lot of kind of like theoretical arguments about the robust outcome test, but there's a big question here, which is what happens in practice. So one possibility that I haven't maybe totally owned up to so far is that maybe it's sort of like correct in the sense that it never says discrimination when actually something else is going on. But it's entirely consistent with everything that I've told you so far, that in any kind of real world scenario, it's just inconclusive and you never actually learn anything when you run it. So to kind of test this, we're going to analyze whether law enforcement agencies are applying uniform evidentiary standards to people of different races, which is, I think, the most common application of the sort of Becker's standard outcome test. So the American criminal justice system is very, very fragmented, and state and local law enforcement agencies vary very widely in the kinds of administrative data that they collect. Excuse me. Integrated policing data is actually very hard to come by, but California in particular has what's called the Racial Identity and Profiling Act, or RIPA. And RIPA mandates that California law enforcement agencies record kind of detailed information about police stops in a standardized way all across the state. So the law was originally passed in 2015, and it initially only applied to kind of like the very largest agencies in the state. But in 2022, the law came into full effect, meaning that every law enforcement agency in the state had to report this kind of information. And so in particular, the RIPA data from 2022 are quite rich, right? They cover more than 4 million police stops from over 500 law enforcement agencies in the state of California. So to apply the robust outcome test to the RIPA data, we're going to have to kind of reorient ourselves a little bit compared to the lending example. So the analog of the bank giving someone a loan is now an officer searching someone. So I'm going to call how often that happens the decision rate. And the analog of a person repaying their loan is the officer finding some kind of contraband, like a weapon or drugs. And so I'm going to call how often that happens the outcome rate. And let's start by imagining that we just applied Becker's kind of standard outcome test, which amounts to comparing the outcome rates for different groups. And the kind of important thing to keep in mind is because unlike getting a loan, getting searched for contraband is generally something that you don't want to happen to you. Discrimination against Black individuals is going to mean that the threshold for searching them is lower, not higher, right? So that's kind of the reverse of what I've been talking about so far. And so in particular, moving to the left on this graph means that the outcome rate of Black individuals is lower than that of white individuals, which according to the standard outcome test is evidence of discrimination against Black individuals. And moving to the right means that the outcome rate for Black individuals is actually higher, which again, according to standard outcome test, is evidence of discrimination against white individuals. And so this is a little bit weird. So using the standard outcome test, we're basically finding that about 2/3 of departments are discriminating against Black individuals, while the other third are discriminating against white individuals, sometimes like quite dramatically, right? And so this is not like logically impossible or physically impossible, but it definitely contradicts a lot of other evidence, including evidence sometimes about some of the specific agencies that are showing up on the right-hand side of this plot. And so I think as a result, when most people see this, their takeaway is not that 1/3 of California law enforcement agencies discriminate against white pedestrians and motorists, but rather that the outcome test doesn't really have sort of like face validity as a measure of discrimination. And at kind of a higher level, this is really important, say, if you want to use the outcome test in sort of like in court or in policy, because the outcome test points toward discrimination in lots of cases that are not super plausible. It's sort of very easy to dismiss in cases where you think it might be more likely to actually be telling you kind of the correct answer. If we perform the robust outcome test, however, we see what's going on with a lot of the weirdness, right? So in particular, in many of the places where the Black outcome rate was lower, which was suggesting discrimination against Black individuals under Becker's standard outcome test, the decision rate is also higher, right? So the robust outcome test in those cases is still saying that there is discrimination against Black individuals kind of by those agencies. On the other hand, in almost all the places where the white outcome rate was lower, which again seems sort of anomalous, the white decision rate is also lower, right? And so this is related to kind of the inframarginality we were talking about before. In particular, now the robust outcome test is actually saying that it's inconclusive, right? In other words, the robust outcome test seems to be telling us that in many, or maybe even all of these kind of suspect cases where Becker's standard outcome test is suggesting discrimination against white individuals, there's actually not enough statistical evidence, at least on this basis, to reach a clear conclusion about what's going on. So we can see that the robust outcome test confirms the standard outcome test in places where other kinds of evidence suggest that the standard outcome test is correct. And in places where the standard outcome test is kind of running counter to other sorts of evidence, the robust outcome test is indicating that the standard outcome test is not on strong enough statistical footing to reach a firm conclusion. So to sort of like briefly summarize, the point is that the robust outcome test really does have face validity as a measure of discrimination, and that when it does find discrimination, that information is actually sort of actionable in a way that's sort of untrue of the standard outcome test. Okay, so just to kind of like briefly conclude, we began this whole discussion with this question of whether we could draw any conclusions about whether Fels-Wargo was discriminating against minority loan applicants, and where we were imagining that it lent to majority applicants at a higher rate, but majority applicants were repaying their loans at a lower rate. And we concluded that neither the difference in lending rates nor the difference in repayment rates alone could tell us that much about whether Fels-Wargo was making discriminatory lending decisions. But together, if we apply the robust outcome test, and we believe that the risk distributions are approximately monotonic, which as we've seen is, I think, a reasonable assumption here, then we have relatively clear statistical evidence of discrimination. Okay, thank you all very much for your attention. There's a lot of details here that I had to gloss over, so if you're interested, I hope you'll read the paper, and I'm happy to take any questions.
All right, everybody, thank you for listening, and Hans for that wonderful talk, and folks on Zoom, if you want to ask questions, feel free to either unmute yourself or to ask in the chat, or of course anybody in the room, feel free to.
I do have a question. Going back a few slides to like when you compare the robust to the simple outcome test.
Which I did a couple times.
Yeah,
Which one?
Most recent.
This one?
Yeah, showing the quadrant where it was like statistically significant versus inconclusive.
Mm-hmm.
Why is the upper right quadrant inconclusive? Is it like a nature of the way that you design the study? Because to me, showing a higher minority decision rate and a higher minority outcome rate, isn't that conclusive just in the reverse direction, that there wasn't?
No, so the conclusive, it's a good question. So they're kind of like, if you do the robust outcome test on this plot, basically, these two quadrants correspond to finding discrimination. So this quadrant corresponds to finding discrimination against Black individuals, and this quadrant would correspond to finding discrimination against white individuals. So what's happening in this quadrant is we're saying the outcome rate is lower, right? So searches are less productive. People are finding contraband less often when they search them, which suggests that they're searching lots of people who have a low probability of having contraband. And also they're searching more people, right? So that this is sort of the outcome test. Going this way says the outcome test says there's discrimination, and going up says the benchmark test says there's discrimination. Since they agree, then the robust outcome test says, yes, there is discrimination. But in this case, they disagree, because the outcome test is saying that there's discrimination against white people, but the benchmark test is saying that there's discrimination against Black people. And then this quadrant is where they're both saying there's discrimination against white people. Does that make sense?
Yeah, it makes sense.
Okay, great.
Going back a few more to where you have the like color-coded blue, yellow, and yes. Do you have any just like intuition for what would make, you know, the standard outcome test like asymmetrical in these ways that you see?
So
like, what's
why is
happening
it not?
underneath?
Why is it not why is it curved or?
Yeah, exactly.
Well,
You know,
so I
just
think
like what causes the imbalance in sort of in like what's happening with the risk distributions that causes?
Yeah. So I actually want to flip to, I don't know how to show two slides at the same time. So I'm going to flip to a different slide that I think kind of the picture is helpful for understanding what's going on. So remember we had this counter example, right? And we have our two groups, and they have sort of different base rates, right? So the base rate, I don't actually know off the top of my, oh no, I think across the whole distribution. So imagine you lend to everybody, then in that case, the repayment rate for the minority group should, I think, be 2/3. And for the majority group, it should be 1/3, right? And so in that case, what's going to happen is, in this case, we have a non-discriminatory lending policy. We lend with the same threshold to everyone. but the repayment rate is still higher for the minority group, right? So that means that we could preferentially lend to the minority group and that would bring their average repayment rate down. But we'd have to sort of there's like a gap, like we have to go, a certain distance before it would equal this red repayment rate, right? And the more different those two groups are, the wider that gap essentially has to be before you sort of cross. And now the outcome test is going to say there's discrimination. And so if the two risk distributions look very similar, then the test is very, very sensitive in the sense that it'll be conclusive even in cases where there's very little discrimination, right? If you imagine in the extreme, if the two risk distributions are literally identical, you don't even need to run both tests, right? Like you can do essentially anything you do will like correctly pick up that you're making decisions differently for one group compared to the other. And then the more different the base rates are, the more difficult it becomes to pick up on discrimination. But when you do pick up on it, you're like, you're like sort of more confident because you're like, this has to be a huge difference, right? It's a very robust finding.
And if you go back to that chart,
Oops. Sorry, I have a lot of transitions in my slides. Okay.
Yeah. So, am I correct in understanding that like this one on the bottom here, the third one, that's
This one.
Yeah, still, or maybe this one, the second one on the bottom.
So the recidivism standard outcome test.
Yes, thank you.
Mhm.
That's like, it's not like flipped. It's not like 100% wrong. It's still getting it right in something like
Yes. So
30%.
in cases where you have, so the distance off the diagonal is essentially telling you how different the thresholds are, right? So if the thresholds are super, super high and they're only a little bit different, then you have some sensitivity. But if they're more towards the middle, so this is saying that in this case, if the black lending threshold is 0, and the white lending threshold is 50%, you're barely picking up that there's discrimination, right? But that's like huge.
Okay. I think I was just confused because I think when you started the other examples, like the discrimination's on the top.
Yeah, this is one.
Here it's just because of the scenario.
Yeah, right. It's because you don't want to be denied bail. You do want to get a loan. You do want to get into law school. You don't want to be searched for contraband. Did you have a question, George?
Yeah, I'm curious. I'm curious about the role of observables.
Mhm.
Do you think it's possible that, let's say if they're let's say if I don't want to say the wrong name was reported, this fictional bank. Let's say this fictional bank intentionally or unintentionally collects different observables from different groups. And so they're making some estimate of risk and that estimate is wrong. And then because risk kind of propagates forward, how would that play into all of this?
Yeah.
You basically have measurement error that's disproportionate across groups in your observables from say this institution. Would it be possible where you could pass this test, but there would be discrimination if the risk was properly estimated, but we've kind of made it improperly estimated by organizational metrics?
So
I'm curious how that plays.
It's a really interesting question. So in some sense, the test is for the test is going to look at kind of people's real probability of repayment rather than so let's say the bank has miscalibrated estimates of repayment probability. It's just systematically underestimates the probability that one group will repay their loans, right? And it uses those miscalibrated repayment probabilities. And in some sense, the bank is trying to do the right thing. So maybe it has a uniform threshold for on that sort of repayment probability, and it lends to people when their sort of miscalibrated score exceeds that threshold. So in some sense, that is in terms of, not necessarily in terms of the bank's intentions, but in terms of its actual actions, that is equivalent to the bank having two different thresholds with a calibrated, with a correct risk score. And so the test is going to correctly pick up that when you look at the quote unquote correct risk scores, you effectively have two different thresholds for the two different groups. Now there is and since this is recording and since I'm a lawyer, I don't want to get myself in like too much trouble, but there is kind of an important legal question here, right? Which is, so they're like kind of these two magic words in the law relating to discrimination, this idea of disparate treatment and disparate impact, right? And usually the way people gloss this is that disparate treatment is when you sort of intentionally treat different groups of people differently out of animus because you want to harm one of the groups. And disparate impact is when you sort of do a, potentially sort of like race blind or gender blind policy, but that just happens to sort of lead to bad outcomes in an unjustified way for one of those groups. And so this does not exactly map onto either of those notions, right? The thing that it maps onto is literally, in some sense, this idea of the two thresholds. But the scenario that you just proposed, you could imagine in the scenario where the bank sort of intentionally has two different thresholds, that's sort of like pretty much textbook disparate treatment. In the case that you're proposing, it's more like disparate impact, right? It's the bank is trying to do some, it's like not intentionally doing something worse for one group than for the other, but it's doing something kind of wrong. And as a result of doing something wrong, you sort of like effectively have a different lending standard for one group than for the other.
I see.
I have a question from Magnus in the chat.
Mm-hmm.
Magnus says, you focused on minority-majority groups, but as we saw in the Black, Hispanic, white plots regarding monotonicity, there's often more than one group in a sensitive attribute and possibly multiple sensitive attributes. Have you thought about how to extend the test to these scenarios?
Yeah, it's an interesting question. One thing is, it's an interesting question. I think the 2-second answer is that probably I would just do all of the pairwise comparisons. So although in a lot of these cases, there is typically like a group that there's like a group that you'd be interested in discrimination relative to. I don't think I've seen, I could be wrong about this, but I'm not aware of any fair lending cases that revolve around different lending standards for different like racial minority groups. I think it's almost always a racial minority group versus, for instance, white borrowers rather. If you wanted to do all of them kind of at the same time, it gets a little bit complicated because, so this is something that I didn't really talk about. Oh, that's why it's not going. Okay, so we were imagining, when I was talking about this in the talk, we were always imagining that the bank had sort of a threshold, right? That is perfectly rational in the sense that it didn't lend to anyone whose repayment probability was less than the threshold. It lent to everybody whose repayment rate is more than the threshold. In reality, for a lot of the applications I talked about, that's maybe not a super reasonable assumption. You can relax this to an idea of sort of quasi-rationality where you have kind of a smooth curve that's like increasing in risk, right? So as somebody becomes more likely to have contraband, you imagine they're more likely to be frisked, but it doesn't have to be the case that literally there's some well-defined threshold at which they have a 100% chance of getting frisked, and below it, they have a 0% chance of getting frisked. And so the sort of complication here is the definition of discrimination that I'm working with now in a mathematical sense is one of these curves always above the other one? And in particular, if the two curves cross, it's not entirely clear whether you should say that there's discrimination or not. And if you have multiple groups, there's sort of, you could imagine like if I overlaid like the decision curves for more groups, there's sort of lots of opportunities for things to cross. And so it's not entirely obvious, I think, what the right way to sort of like deal with that is. If you imagine that all the curves have this property that they sort of are ordered, that one lies on top of the other, the way that I have them here, then you could just do the pairwise comparisons the way I was saying, and it would give you kind of the right answers. But yeah, it's an interesting question.
So we probably have time for maybe one more question, and nobody else is asking it in the room. I'm going to ask it.
Okay.
Which is this. So, I mean, I think this maybe in some sense is related to George's question, right? But I feel like, one of the great strengths of all of these tests is their simplicity, right? You don't need to use information on X at all to carry out the test. And so, I guess I can't help but feel like you're leaving information on the table.
Definitely.
In all of these tests, and I'm wondering, like, have you thought about ways to incorporate covariates in maybe some of, to lend, to maybe deal with some of the situations where the robust outcome test is inconclusive. And one idea is potentially using covariates to assess the likelihood or assess whether the plausibility of the monotonicity property, if you assume that you can accurately estimate risk for everything.
Yeah, I think this is a really interesting question. And the 60-second answer is probably not going to be super satisfactory, but I think this is really interesting. I think that the sort of like the trade-off for the robust outcome test is you're making a much weaker sort of mathematical assumption than you would otherwise be making, but that also entails some loss of efficiency, right? Like if there were a parametric assumption you really believed and you made that, you would be able to sort of say a lot more than you can this way. So it's definitely sort of like conservative in that sense. Although as we saw, like in a lot of examples, it still is finding discrimination kind of like despite that. I think so the two extremes are like, in one case, you have no covariate information, then you kind of more or less have to do this. You don't really have any other options.
Yeah.
In the other extreme, let's imagine you have the same covariates as the decision maker. Then you can just reconstruct the decision maker's decision function directly in some sense, right? And so you don't need to do this at like, this test is telling us whether the thresholds are different, but if we have enough information to just estimate the thresholds, we could just estimate the thresholds and compare them that way. And so I think that the interesting case is when you have some covariate information, not enough to sort of accurately reconstruct the decision functions, but enough to know something. And I think in that case, it is an open problem to figure out what the right way to incorporate that information is. And I think I have some like tentative thoughts about how you might do that. But it's the mathematical setup makes it kind of hard to figure out how you would do that without sort of introducing a lot of sort of much stronger kind of extraneous assumptions. So I'm definitely interested in that question. I don't have a great answer at the moment.
All right, well, let's thank Hans again for a really wonderful talk, and thanks everybody for attending. This is, I believe, our last PRISM seminar of the semester, and so hopefully we'll see many of you next semester when we have our next lineup of speakers. So thanks again, everybody, and Hans in particular.
Thank you all for coming.